Welcome everyone. Thank you for joining us for today's webinar. Welcome back to Guest Indonesia Digital Series, which is a series of activities from Guest Indonesia 2020 event. My name is Farah Karima as your MC, and present with me today as a speaker, Ms. Jayme Brown, Director of Global Education Overseas, Business Division of LUXROBO, and Mr. Andre Kalinescu, Technical Solution Consultants of LUXROBO. Jayme Brown has been working and living in Korea for the past 18 years, but is originally from Canada. She has been working in the education industry for nearly 20 years. And Jayme has a love of learning languages, travel, and meeting new people. While Andre is currently in Seoul, South Korea, but has lived and worked in 3 other countries. He's a self-taught coder dedicated to spreading the joy of coding far and wide. And today, both of them will be presenting Coding Education by LUXROBO. And now, without further ado, I will turn the time over to Jayme and Andre.
Okay, so I'm going to turn on screen sharing. I hope everyone can see my screen. All right. All right, can everyone see my screen? Okay, good. All right, well, hi everyone. Welcome to LUXROBO's virtual booth. We are a robotics and coding education company in Seoul, South Korea. We're very happy to be able to show you our best-selling modular robotics kit, Modi, today. Nice to meet you. So this is the first robot to walk the earth. In Greek myth from the time of Homer was a bronze giant called Talos, forged by Hephaestus, the blacksmith god of technology. In fact, the word automation is self-moving, was used by Homer a very long time ago to describe the many animated devices fabricated by Hephaestus. Talos could use his heat metal body, and it was hot red, and it could hug victims in his chest, roasting them alive. In the legend, Talos was made and not born. Even the ancient Greeks were imagining AI education and robots. So we'll just talk a little bit about the past and robots. The Unimate was the first industrial robot ever built. It was a hydraulic manipulator arm that could perform repetitive tasks. It was used by car makers to automate metalworking and welding processes. By the 21st century, interactive robo-pets, also known as smart toys, went on sale. This was the realization of the dreams of the toy makers and inventors from the 18th century. For example, the canard dirigateur, you can see this at the very top of the slide, right here. This is the interior of the automatic duck. This was an automation in the form of a duck created by Jacques de Vaucanson and unveiled on 30th May 1739 in France. In the late 1990s, the Kismet was a robot made as an experiment in affective computing. And on May 11th, 1999, the Aibo was released. The Aibo means partner or pal in Japanese. It was made by Sony. In 2002, the first autonomous vacuum cleaner learns to navigate and clean homes. We all need one of these. So here you can see more industrial robots for manufacturing. And we can see another Amazon Kiva for other factories. So now we come to the present. Think about your hometown or the last time you went on a trip. Are there any self-driving vehicles there? Or what about trains? In hospitals, mobile robots provide food service and delivery to patients. Isn't that amazing? So nowadays we have lots of different robots and robotic devices. And now we're going to show you a little bit about our robotics devices in our company. So Andre is going to show us a video to talk about our modules and what they can do. So Andre, please show us a quick introductory video.
Wanna make something? Modi.
All right, so this was one of our videos to show our devices. And now I'm going to start to talk about some of the modules that you can see in our brochure. All right, okay. So now I'm going to briefly introduce you to our kits. First, you can see our Hello IoT kit. This kit has 7 modules, and it's a great starter pack for those who are new to coding. Underneath it, down here, you can see our making pack. This is a great add-on. You can use this pack to make lots of cool projects, and spark your creativity. Our next kit is our expert kit. This kit has more modules and is much more advanced. Later, Andre is going to show us a lot of our modules, so we'll get to see some fun coding too. This kit has a lot of available resources such as videos, PowerPoints, activity sheets, user manuals, as well as a drag and drop coding tool, Modi Studio, and our cell phone app Modi Play. And coming very soon, it's going to be compatible with Scratch. We also have our master kit. This is popular in high schools and universities. And for more information about these products, you can reach out to us at any time. We'll show you a little bit more about these during the presentation. Here you can see Modi Studio. This is our exclusive coding program where you can do drag and drop coding. And then we have our Modi Play application that you can use on your cell phone, where you can use buttons, joysticks, sliders, dials, and timers, remote control, things like that. So now Andre is going to show us another video to show you our compatibility with Lego.
Alexa, light up the cabin. Alexa, move the truck forward.
All right. So now we're going to show you more about our modular robotics kits, and Andre is going to show them in the screen. Our modular robotics kits have 3 kinds of sensors in them. We have input, output, and setup, and these are all color-coded. So Andre, show an input, show an output, and let's show a setup. Okay. So today we're going to learn about the innovation of each type of module. And like I said, Andre will show you everything on the screen as I talk about each one. Later, we'll do a live coding demo for you too. So as you can see here, we see that input modules, they use sensors and they detect objects around you in the real world. And our output sensors, they show results with various modules. And our setup sensors You can use your network module to connect and use drag and drop coding. So not only our network module, but we have one more module. There's also a setup, and that is our battery module. So these are all of the modules in our expert kit, and 3 of the module names are missing. So here we have our button, and then the next one, Andre is holding it up. This is our dial module. Then next here we have our mic, and we have our ultrasonic, LED, and then this one is missing. This is our speaker module. Then we have display, network, infrared, environment, gyroscope, ultrasonic, motor controller, and motor. And then finally, the last one, what is it, Andre?
Battery.
This is our battery. And this one gives us power. So now we'll explain a little bit about how our input modules work. Okay, so how do you detect the world around you? And how do you know there are birds singing outside or there's a car on the street? You know because you hear or see them. We have 5 senses. These are touch, sight, hearing, smell, and taste. These senses are essential to our survival, and they allow us to detect the world around us. Just like our input modules sense and detect specific information about our surroundings. We can also think of these senses as inputs. Without them, our brain would receive no information about the world. So input, hearing. Our ear detects sound volume and frequency just like a microphone. So here Andre is showing you our microphone module. So here are some examples of microphones in the real world. Our next input is vision. So we have 2 modules that act like vision. So one is our environment module, and the other is our infrared module. And later, we're going to do a quick demonstration to see how the modules work. Here are some light sensors in the real world. So another cool input we have is the vestibular system. This is a little bit hard to understand, but it's pretty cool. This is located in our inner ear, and it detects the orientation and acceleration of our head in the 3 axes, which is X, Y, Z, just like our MODI gyroscope module. That's right, we have 2 gyroscopes in our head. So here we can see some gyroscopes in the real world. And so later, Andre is going to show us something cool we can do with the gyroscope. So this time we'll learn about output. So we don't only have input inside of our modules. You can see the output that we have, and we use outputs to affect the world around us. So for example, we can move things with our muscles. They use energy and they produce motion. So the motor module uses electricity and produces motion. So here you can see some motors in the real world. So another kind of output is voice. This is something that humans use a lot. We can produce sound with our voice box and our mouth. So we also use energy to produce sound. So our MODI speaker module uses electricity to produce sound. So we have to use more than one module for this. Which other module do we need, Andre?
I just added the button, but we can use a whole bunch of other inputs.
That's right. So here we can see some speakers in the real world. So now we're going to move on to our setup. So energy is essential for us and for machines. We use energy from food to live and interact with the world around us, and we need energy for our senses to process inputs and for us to produce output. Just like us, MODI needs energy too. The battery provides the electrical energy that input and output modules need to function. So here we can see different examples of batteries in the real world. And for the last one, we have another setup. So without the brain, nothing would work. We use our brain to learn and plan what we need to do. Our brain processes inputs from our senses, then plans and executes the outputs. Our network module uploads our code to the other modules so they know what to do. The code tells them how to process and interpret inputs and produce the outputs. Computer chips are like brains for machines. So everything with Modi is input, output, and setup. Here's another example. And here's one more. And like I said, later, Andre is going to show us some cool stuff that we can do very shortly. So why Modi? So the first reason is that Modi connects you to real life. So before you saw where you could find different things and different modules in real life. So here we have our LED module. Here's some examples of where we can find LED in real life. So we have traffic signals, remote controls, nail lamps. Here we have our speakers. When you go to the movie theater or you use your cell phone, you have speakers inside. And also we have our display module. If you have a smartwatch or a computer LCD monitor, or even if you have an electric oven at home, these are all good examples of displays. So Modi also helps you to build and create something new. So here you can see some really cool 3D printing projects that you can make with Modi. Here we have our smart plant that uses various modules. We have our Viking, and then here we have a racing track that measures speed. Modi also puts you in the director's seat, and it helps you to create new things on your own. You can be very creative with Modi. So Andre is going to show us how to make a few cool creations using different modules. And the first thing he's going to do is try to make a flashlight, and he's going to explain the process. Andre?
Sure. So of course we need a bulb, in this case an LED, and we need a way to turn it on, which is a button. But it's not turning on because we don't have energy. So we have the battery, and there we go. It turns on when I press the button.
All right. So if we want to change our flashlight and make it more interesting, make it dim or turn up or down, and use a different module, how can we do that?
There we go. I just swapped out the button for the dial.
So remember before we saw our gyroscope with the X, Y, Z axes and the vestibular system. If we use our gyroscope module, Andre, what can we do?
So I've just taken the gyroscope and added it as the input, and you can see that the color of the light changes as I'm rotating the creation, because it's taking the XYZ rotation information from the gyroscope and it's converting that into RGB light.
That's great. I hope everyone can hear Andre. I hope he's not on mute. So I'll move the microphone over. So here, just as a side note, everybody can know that the order and direction of the modules as Andre puts them together don't really matter. So Andre can show you. We get the same result no matter how you connect the modules. Also, Modi helps you to build important life skills. And some of the skills you can learn: problem solving, creativity, collaboration, decision making, integrated skills, and computational thinking. So next, Andre is going to talk a little bit about safety. Andre?
Sure. So unlike a lot of products for robotics for kids, you can see that our pins are really discreet. They're very tiny, and they tuck away when not in use. So there's no sharp components. There's no danger from connecting these modules. They connect securely with magnets, and they're very, very safe. And one more thing is you can't really short them. You can't make a short circuit by connecting two batteries. Normally that'd be a really bad idea with most other products, but you can see that nothing happens. They're both charged, but they're safe.
So this is really good for small kids because there's no risk of sharp parts, bent pins, short circuits, or backwards connections. So really safe for little kids and little fingers. So Modi is also intuitive, and Andre, again, is going to talk about Modi Studio and our CUI and GUI just very briefly.
So as you'll see soon when I demonstrate, the Modi Studio has a very intuitive user interface. It uses drag and drop block coding, so it's very easy. Just drag over the components you need and the features you need, and just like that, you've created something. And if you get curious and want to see the actual code that is generated from the block coding, you can just switch over from GUI, which is graphical user interface, to CUI, which is coding user interface, and it will display all the C++ code that you just generated with your block coding. Anytime you make a change to your block coding, the C++ gets updated. So it's really great to show you a peek of what's ahead on your coding journey.
Great. And then the last one is compatibility. Okay, Andre, do you want to talk about the microcontroller?
Sure. So the really nice thing about Modi compared to other products is every module is intelligent. There's a microcontroller in every module. There isn't one module that is required to be a hub in every project. Usually those hubs are kind of bulky, so it's really nice to avoid using them if you don't need them. And with Modi, you don't need them. So you can upload your code and use only the modules that you need and no more. Your creations can stay small and elegant and integrate very nicely with your Lego or 3D printing projects.
That's right. Good. So like we said before, Modi is also Lego compatible. And here you can see our different language compatibilities. We have entry. This is the Korean version of Scratch, C++, Python. We have a few new products that are using Python, Arduino, and Scratch. And we're also able to use our products on different devices. You can use your laptop, you can use a tablet, and you can use our Modi Play on your cell phone device with Bluetooth connectivity. So the other cool thing about Modi is that it really does help with creativity. And so today we're going to show you a really cool activity, one of our 3D printing projects called the Modi Weather Project. And so we usually ask our students, how's the weather today? And right now in Korea, it's fall, so the weather is nice and cool. This would be a nice breezy night in Korea. So here we have a picture of our weather station that we made, and Andre actually has it with him. So we are going to show different kinds of weather here. So Andre is showing a picture of the house. Okay. So what do you think will happen when we shine light on the environment module? So nobody can write their answer in the comments right now or on the screen, but we're going to show you what happens. So these are the different modules that we're going to use for this presentation. We have our display, our battery, our infrared, our environment module, our motor controller, and both of our motors. So let's find out how the Modi weather station works. So at the very top of the weather station, here you can see our infrared module. So this module will detect whether it's windy or not. And then here you can see our other modules. This is our environment module. This will detect light. And this is our display module. This will show the weather condition that is being detected by the environment module or the infrared module. So we made an algorithm for our coding. So if it is sunny, the windows on the house are going to open 100%. And Andre is going to code so that the windows open 100%. So if it's windy, the windows will close 100%. And if it's cloudy, the windows will open only 50%. So now Andre is going to do a live demonstration for coding to show you how to code the Modi weather station with our Modi Studio coding tool. Andre, please unmute yourself.
All right. I'm not sure if my screen is working. I think it's still loading.
Okay.
Let me know when you can see it.
Okay, we're still loading. I'll let you know when we can see it.
Let me know. I'm going to try again.
Okay, let's try again. We're having some technical difficulty. If we can't show the live,
I think it works now.
All right, so first off, we need our network module, and we're going to connect that to our USB cable.
You can see it's detected by Modi right away,
as well as the cheeky down module will be there. There we go.
There we go.
Okay, so now we need to gather our module we're going to need for this project, which includes the display and the infrared. Oh, I connected it by accident. That's okay. They can go away. All right. So we just added the environment. And last one is the motor controller. Great. So we have all the modules we need. We're going to start off with an if block. So if the infrared proximity mode is less than or equals to 60, then we're going to give our motor some settings. This will be angle values, and we're going to tell it to go to 0% and 50% of its range. And we're going to show a nice, beautiful drawing on the display. This is for the windy conditions, so this will be the wind. And we're going to add a little delay here. 500 milliseconds sounds good. Next, we grab an else if block, and we use the environment. And the illuminance, if it's over or equal to 85, then the motor is going to have angle values of 50% and 0%. And once more, oh, not text. We're going to do a nice masterpiece here. This is for the sunny condition. Oh, I guess I didn't do a good enough job there. There we go. That's the best I can do. And last, we're going to put an else block. Oh, not there. We're just going to put it here. And that one doesn't need any special conditions. It will tell our motors to go to angle of 25% and 25%. And one more masterpiece. This one will be for a cloudy condition. So I'm just going to do a quick little cloud here. Okay, and that's it. I'm going to upload the code to our module.
Andre is an artist.
I think you're muted.
Oh.
I think Andre is a good artist. Okay, am I sharing again? All right, do you want to mute yourself again, Andre?
Sure.
All right, I'm going to share my microphone with you. Okay, so like we said before, we had our own algorithm. I'll just tell you the algorithm again, just so everyone can remember. So when it's sunny, the windows are going to open 100%. When it's windy, the windows are going to close 100%. And when it's cloudy, the windows will be at 50%. So right now, it's cloudy. So Andre, let's make it windy.
Okay, we've got the wind right here.
That's right. So right now, the windows are closing 100%. So that means Andre did the code right. He coded correctly. Good job.
I get to keep my job.
We'll keep you for a little while. All right. So let's try sunny.
Okay, I've got the sun right here.
That's right.
Looks good.
So when it's sunny, that's right, the windows open 100%. There you go. Great job. So does the window open or close when it's sunny or cloudy?
I think it does.
It does. And does the window open or close when it's windy? It
closes.
does. It closes. That's right. All right. So, Andre, do we have anything else that we want to add?
No, I think that was it.
All right. So this is the end of our presentation. We want to say thank you to Guess Indonesia for letting us host. And could we have our host again, Miss Farah? Could you give us the greetings again?
Yeah, thank you very much, Jayme and Andre. It was a pleasure to have both of you with us. We hope everyone have learned and enjoyed this amazing presentation. So this concludes the webinar, and thank you for joining us today, and we will see you at the next Guess Indonesia digital series. To get a complete information, please contact us at marketing@tarsus.co.id and follow our conference streams for 2 days, 4 and 5 November 2020. Stay tuned and don't miss it.
Thank you very much.
Thank you.